and come over here, and we're going to be working on, again, a little bit of section 10.6, but I've also had some questions from some other web work questions because there's quite like 3 of them due or something like that opened up still right now. That's coming due because of all the different types, cross products, dot products, surfaces and the like. So you've got several web work sets coming up, and some people were having some issues with some of the web work. So I decided to grab a few of those and in particular to take a look at to show you you're making this stuff a lot harder than it has to be. And then I thought we would right towards the end, you have your test review. It is due on Monday at the beginning of class. I was going to go over any kind of questions you had on that. Your test is on Wednesday, and then I'm marching on to move on to section 10.7, functional curves, because, hey, we haven't really actually done any real calculus yet. We've done vector stuff, but you got to get a good foundation of this. We're going to be taking derivatives and talking about the derivative of these vectors and what they look like. So we're looking at position vectors and the like. That's where I'm going next. Calculus is literally just across the curve. And so just around the corner here. So we are going to be focusing on this concept, but you got to get a good feel for vectors before you can do this vector analysis stuff that we're going to be doing. So here we go. So with that being said, let me switch over here to this, my dot cam. And so I did last time, I did this particular picture and stuff, and I did a bunch of problems for you guys. And just to remind you of the problems I did, but I wanted to pick up just a couple more on this thing. And again, for example, get over here, taking a look at something like this. Now, this is more or less, can you figure out which equation matches with which pictures? And you got to love, now you're getting the more advanced web work questions. So I got a question for you. How many pictures I got up here? How many ones do I have to match up? Yeah, it sucks. I don't even match up anymore. At least in the old days of Calc 1 and Calc 2, there was 4 pictures and 4 questions, and obviously 1 question per answer there, and I could get it. Oh no, now you're in trouble here. So they have more pictures than answers here. So, but you got to get a feel for, and again, it's all about this visual stuff. So, and I kind of want to do one of them for you guys, and the one I really want to focus on is either 3 or 4. See, these guys should be pretty straightforward. The x squared plus y squared plus z minus 1 squared equals 9/4. That's going to be a sphere. Where's the center of the sphere at? 0, 0. What's the z coordinate going to be? -1, and the radius would be 3/2, which would be kind of small. And then I try to figure out based upon the coordinate where that point 1, 0, 0, -1 is going to be. So x is 0, y is 0, z is -1. So that's going to be going down the z-axis here. So it's going to be going down -1. And it looks like this guy right here, down -1, but it's got a radius of 1.5, 3/2. So I do believe, based upon my abilities, that answer would be C. And again, you will get a better picture with this stuff when you're on a web work. And you can click on the picture and you can blow it up or make it smaller and move it around if you need to. So, nice thing about web work. But the one that I wanted to look at was like number 3 or number 4. I don't care which one I do. So let's pick one. How about number 3? Because it's got a fraction in it. All right, so here it is, number 3. So I've got x squared plus y squared minus 4x minus 4y, okay, plus z squared over there, minus a 2z is equal to -35/4. Well, what you want to do on this one, because you need it in that x minus h squared plus y minus k squared plus z minus l squared is equal to r squared equation of a sphere, you're going to have to complete the square. So a lot of the times we kind of mess these guys up, but to complete the square, get all your x's together. So this would be x squared minus 4x, leave a little space, get your y's together, plus y squared minus 4y, leave a little space, plus get your z's together, z squared minus 2z is equal to, if you had a constant over here, move it to the other side, make -35/4. Now, to complete the square, you will notice that the coefficient in front of your squared terms are all 1. That's nice. If it's not, you need to factor it out. Then you end up getting something like, if they're not all the same coefficient in front of the x squared, y squared, and z squared, that means you're going to get an ellipse. They got to be all, if they're all the same. Now we can mess you up and go 5x squared plus 5y squared plus 5z squared. That's still an equation of a circle because all the coefficients are the same. That's going to make circles. But if the coefficient from the squares are different, that's going to make ellipses out of it. Okay. But this one are all one. So once they're one, what you got to do to complete squares, you take, remember the old days of high school algebra here, you take 1/2 the b term. The b term is the coefficient from the single variable, square it and add that to your term to complete the square. And remember, this is an equation. So what you do to one side, you do to the other. So on the x's, the b term is -4. So you're going to take 1/2 of -4 and you're going to square it. Half of -4 is -2 squared is 4. So I'm going to add 4 to both sides. What I do to one side, I do to the other. Same idea with the y's. The b term is -4 again. So half of that would be -2 squared is 4. So I'm going to add 4 again to both sides. The z, the coefficient in front of the z is -2. So you take half of -2, which will be -1, and square it. That's 1. So I'm going to add 1 to both sides. Okay, adding 1. Now, when you put it together, these x's are going to factor perfectly. It'll be the same thing times themselves. So what is x squared minus 4x plus 4? That's going to be x minus 2 times x minus 2, or better yet, x minus 2 squared. Plus the y squared minus 4y plus 4. When you complete the square on that, and with that's completed square, this will factor perfectly as y minus 2 squared. And now look at the z's, it's x squared minus 2x plus 1. That will factor perfectly as z, in this case, minus 1 squared. Z minus 1 times z minus 1 is equal to, now because of crappy -35 fraction here, I'm going to put this one on the old handy dandy calculator. -35 divided by 4 plus 4 plus 4 plus 1 gives me a positive 0.25. And okay, for you people that don't know that math fraction, that's 1/4. That's still 1/4 there underneath my light source. 1/4. Now, that's what I needed to do to get this equation in terms of the right format so I could visualize it. Where's the center point at? So my center is going to be at what point? 2, 2, 1. What would my radius? Remember, this is r squared is equal to 1/4. This was nice. So what does that make my radius? Square root of 1/4, which is 1/2, right? So I've got to look for an equation or a sphere, if you will, centered at the point 2, x is 2, y is 2, z is 1, so it's in the first octave there. X is 2, so this is your x-axis, x is 2. It's got to move over in this direction 2. Be careful on this. This y is in the x is this way, so it's 2. Y has got to be 2 as well. So it's got to be over here. That's not it. So x is 2. There's your x-axis. Y is 2. Z is 1. And the radius has got to be 1/2. So this one is looking more promising to me. This one, though clearly your radius is just way too big there. This one, x is 2. Y is 2. Z is 1. Radius 1/2. Wait a minute. Nope. I like this one better. This one looks like it's a radius. If I go x is 2 and y is 2, that would, there's 2 right there. That would have been back over here. So this is not my guy. This must be my guy. But you notice how painstakingly I sit there and take my time and try to figure it out, because it is tough to see these guys. But again, a little bit more of an advantage when you're actually on WebWorks and click on the picture and blow it up and get a better view of what's going on here. And it's also in color. So that helps. Does that make sense? All right, so I want to show you that one. So that one, and this is another one that tends to throw people off here. Okay. So this one, let me slide it up. You guys can see this. This is problem number 6 on that particular homework set. All right. And that is identify the problem here. Identify the type of quadratic surface defined by this equation. I got 36x squared minus 25y squared plus z squared equals 1. So you only got like one chance of this. Don't screw it up. So pick the right guy. You notice we did kind of restrict the number of attempts, just to let you know. And then you got to figure out the x-intercept, y-intercept, and z-intercept. That's really what I was looking for and stuff like that. Okay. So with this one right here we go. All right. This guy is 36x squared minus 25y squared plus z squared equals 1. Now, you know, when we looked at all these surfaces, and I'm going to grab this little sheet over here, this is what we have memorized. But if you notice, each one of these guys, the coefficients are in the denominator in this standard form. Does that make sense? So how do I get these coefficients in the denominator? Well, I got 36x squared. Here's the trick. Well, make him a fraction and put him in the denominator. So this would be x squared, but it'll be a fraction of 1 over 36 minus y squared over 1 over 25 plus, that's just 1, z squared 50 over 1 is equal to 1. It's the exact same equation. But these coefficients I put in the denominator to make little fractions. So this sucker is going to be real small in terms of these things going on here. Now, with this, here we go. What ends up being your, what is this thing going to look like? Well, you'll notice here, I've got one, they're all squared. First off, every one of them squared. I've got 2 positives and 1 negative. Does that make sense? 2 positives and 1 negative, squared terms. 2 positives and 1 squared equal to 1. 2 positives and 1 negative equal to 1. What's this guy's name? Hyperbola of 1 sheet. So this is going to be the hyperbola of 1 sheet. Hyperboloid of 1 sheet here. Okay, hyperboloid, let's see here, of 1 sheet. There's the actual guy. And again, it's the variables all being squared and it's the sign of them. Now, with that, again, this one right here, this one is x squared plus y squared. That gives you the ellipse, and the minus z squared. The minus z squared makes the hyperbolas this way. What are we doing here? We got the minus the y squared. The x squared and the z squareds are positive. So if I was going to get a general shape of this guy, again, I'm not going to be more specific. I can, but you guys don't pay me enough. So general shape of this guy is going to look like what? Well, the negative guy is where the hyperbola is going to be. This would be, and again, trying to describe this thing. This is a minus z squared. So along the z-axis is where the hyperbola, the hyperbola part is going to be at for your hyperboloid. So this one is the y squared. So this thing is going to look like this, and up here, and down here. And if you get rid of the y and the xz plane, the y equals 0. That's an equation of an ellipse. So it's going to look like this. It's going to look like this over here and this. So it's running this way versus running up and down with your hyperbola of 1 sheet. Does that make sense? I'm trying to give you a feel for this stuff because you got to have practice with this material. It doesn't come naturally. There is a pattern of what I'm doing. But at the end of the day, you'll notice I keep referencing this. For your benefit, I got this memorized. You should too before the test on Wednesday. Okay. So there you go. And so in terms of the intercepts and the like here, and these guys, how do I find the x-intercepts? You set pretty much y equals, the other variable is equal to 0. And so if you'll notice over here, this will be your x squared over a would be 1 over 6. The 6 squared is that 36 thing here. Minus y squared over 1 over 1 over 5. Well, 5 squared is 25. Plus z squared over 1 squared equals 1 here. So on this one, my vertices in terms of the x is going to be negative 1, 6 and positive 1, 6. So the x-intercept is going to be, when x is equal to 1, 6 and negative 1, 6, that's when it's going to cross the x-axis type thing here. Well, and again, with the y-intercepts and the like, okay, and again, these numbers here, under the y's, you're going to get plus or minus, if you will, 1 over 5. And on the z's, it's going to be plus or minus 1. And so these are the numbers that go up and down on these guys here. So if you draw this thing out, so the y-intercept is going to be that 1/5 comma negative 1/5 and that 1 negative 1 aspect of this guy here. So that's where they're going to quote unquote be at with this particular material. Okay, so, and again, you know, in terms of, you know, answering enter your answers, enter none if there are no intercepts or whatever the case may be. But again, get a feel for these guys. Now, again, just to talk about it, to give you a better picture, because this was me drawing in very lame terms, give you a visual on this guy. When you actually do this stuff here, you know, I'm basically doing, I'm writing this equation right here, put the stuff on the bottom. So the x squared over a squared, a is 1/6, 1/36. So a is 1/6, so this will be 1/6 here on the x. It'll be negative 1/6 here. So you go through those points. That's what I'm referring to. That's what's going to cross the x-axis. That's your x-intercept, you know, y and 0, 0 there, if you will. 1/25 here on the y, that's your b squared. So that's 1/5. So over here would be a dot, positive 1/5, and over here is negative 1/5. And the z squared is plus or minus, you know, the c squared is 1. That means c is 1 and negative 1 down here. But then this aspect, if you draw it out, this is where that part is going to be at. This right here, if you draw your little box and stuff, this thing's going to run this way, it's going to run this way, going to run this way, and this way, and this. And if you make z equal to a number, move it over here, you get some more ellipses. So now my picture's right. These are the points that I'm referring to when it comes to this stuff. Does that make sense? Just trying not to confuse you guys on this stuff. All right, one more. Take a look at number 7 over here. Again, I'm going to probably have to do the same thing with you guys in terms of my test. And that is sometimes have to figure out that I'm going to force a leading coefficient on one of them. You saw this on web work. That way everybody has the same answer. Because, you know, if I focus on the y's instead of focus on the x's, you know, I could mess up on these parabolas and the ellipses. I'm going to get the same equation, but I want everybody to actually get the same answer. It makes it easier for us to grade. So with that's the real reason for why we're a particular coefficient of some of this stuff. So first off, by completing the square, you know, you want to put this equation in terms of this form. So again, complete the square. I've got x squared plus 8x. Group your x's together. Plus, leave a little space there, or in this case, minus, that is, minus 64y squared, okay? But I don't have any more y's on that one. Well, I leave a little space there, plus z squared minus 16z. Ran out of room, so that's equal to a negative 8. All right, so if I want to complete the square off this guy, all right, take the coefficient from the x squared is 1. You take half the b term, half of 8 is 4, squared is 16. I want to add 16. What I do to one side, I do the other. Do minus 64y squared. There is no y term. So this is already squared. Y squared. You can leave them alone. You got to have a b term. This one doesn't have a b term, so you don't have to complete the square on it. The z, the b term is the negative 16. Half of that would be negative 8. Squared is equal to 4. So I'm going to add 64 to this side and add 64 over here. Now, rewriting my equation, this will factor perfectly. This would be x plus 420 squared minus 64y squared, because it was nothing complete squared, because it's already y squared there, plus z squared minus 16z plus 64. That's going to factor into xz minus 8 squared, and that's equal to, and then I got to run the gamut on the numbers here. That was negative 80 plus 16 plus 64, which makes it 0. That's all there is. Okay. Yeah, I guess it did. Look at the math. All right, so it's equal to 0. Okay. But this is web work, so hang with us here. All right. Into standard form, ax minus x naught squared plus b minus y naught squared plus c minus z naught squared equals d. use your answer to sketch the graph of this quadratic surface on your paper. Okay? Cool. All right. So, and you're supposed to actually write this guy out. So this would be officially 1 times x plus 4 squared. That would be a negative 64 times a y squared plus a 1 times a z minus 820 squared is equal to 0. Okay? Does that make sense? Did I lose you guys anywhere on this thing? Now you're supposed to graph the thing, but what would this equation actually look like? Well, I gotta be making sure it's equal to 0. So, okay, WebWork really likes me. All right, you know what this is gonna look like? Well, it's no longer, I mean, it's been shifted over by one of these guys right here. All these other ones have been centered at the origin. Where's this thing centered at? Where's the center gonna be at? -4, 0, good, because there is no, y minus 0 is still, 0, comma 8, you with me? So it's -4, 1, 2, 3, 4, there, -4 down there, 8, a 0 on the y, so here's your y-axis, and up here at 8, 1, 2, 3, 4, 5, 6, 7, 8, there's 8 right there, so -4, 0, 8, right back there. But if it was one of these hyperboloids, one sheet or whatever, because I got 2 positive and 1 negative, that's what we got. It has to be equal to 1. It's equal to 0. You know what you get? Yeah. Well, okay. You can. All right. So I know I'm going to be to that point. Move this to the other side. So you're left with x plus 4 squared, plus z minus 8 squared is equal to 64y squared. You with me? And then you can divide by 64 if you want to. It may work out a little bit better for you if you did that. Divide by 64. I get y squared is equal to x plus 4 squared over 64 plus z minus 8 squared over 64. So I got one variable squared equals the other's variable squared. And again, grabbing my piece of paper here. One variable squared equals the other 2 variables squared. And what do you end up getting? Very good. I am impressed. Carla, because she said cone, I heard her. There you go. Does that make sense? Recognizing the type and the cone, but it's been shifted over. It's going to be over here and it's going to be a use it to sketch, but it's going to be a cone. Now on this one, again, a little more information here, but this one, it was the z squared. It's opening up and down because the z squared equals the other 2 guys squared. You with me? On this one, it's the y squared. So if you graph it and the y being squared type thing here, even though this has been shifted over, it's the y squared. So it's going to go open up along the y. So it's going to be a cone, looking lack of a better term, it's going to look like this with your cones. Does that make sense? Again, you don't do much on the sketching in terms of this. You just supposed to identify. It is web work. You really don't draw on web work. You pick texture on web work and stuff. But we'll make you guys draw stuff. So based upon that, I got a question for you. Graph this and kind of set me up for this guy right here. Okay. $64 question. What is it? Now, this one is a manipulation of those other 2 guys. So when in doubt, gotta try to get a feel for it. All right. I want to draw this guy. And here's a classic example of what kind of stuff I'm going to put on the test. It's manipulation of my equations. I'll give you one of the basic ones, one of the 6 on that sheet. But I may reserve the right to mess you up and throw something like this on there. See if you can figure it out. X is equal to the square root of x squared plus y squared. Now, officially, you could square both sides, but it would manipulate your equation a little bit. And you would end up getting x squared is equal to y squared plus z squared. And you should recognize, based upon the problem I just did, what this thing should look like. All right, one variable squared is equal to the other variable squared. It's going to be a cone. But when we draw those other cones, when you got the squares, it's z squared equals x squared plus y squared. It opens up and opens down because the square root both sides plus minus. I didn't give you the option of taking the square root. I didn't give you the x squared. So this is going to make a difference. So first off, if you want to look at this thing like this, here's what you should do. Level curves. If you want to draft this thing, you get a feel for it. And if all these formulas get confused after a while, you think you're dead in the water on this thing. You're not. Go with level curves. With level curves, you're talking about making one of the planes. So in one of the planes, I'm going to let y equal 0 plane. This is the best way. If you get confused, best way to figure out what fix is going to look like. Make y equal 0. Then I'm going to make x equal 0. Then I'm going to make z equal z equals 0. Then I'll make x equal to a number if I'm looking for a particular format. You'll see in a second. So y equals 0. I'm going to get this equation. X is equal to the square root of z squared. What does that actually look like? What is the square root of z squared? This is something you should know. It's a definition, actually. What is it? Absolute value of z. Very good. Because it's the positive square root. So it's this guy. You guys know what an absolute value graph looks like? So if this is the x, z plane, it's the v graph. That's what's making that cone. Does that make sense? Square root of x squared is definition is the absolute value of x. Because you can't have the negatives on that thing. Because it's a positive square root. So over here in the xz world, you're going to get this thing coming out looking like that. That's it over here. Okay. No, yeah, and it's on. Oh, and this picture's bad. My fault. This picture's good. This is bad. Sorry about that. It's z equals absolute value. X equals absolute value of z goes this way. It's on the side. My fault on that one. Wish I brought my white out. Don't worry about that. It's this. Okay. Sorry, I was looking at it the other way and just trying to get my point across that I was excited you guys with the absolute value definition. So absolute value of z is the same as square root of z squared, but it opens up along the x. Let me give you an example here. What does y equal to absolute value of x look like? That looks like this, right? There's your y-axis. This is your x-axis. But if you switch it over and put x is equal to absolute value of y, it looks like this. This is still x. This is y. It turns at 90 degrees. This is x equals absolute value of z. It's over here on the x. It's this guy. That's what I was trying to make a point across. So sorry about that. All right. Now let's talk about this one. Let's look at the plane z equals 0. If I do z equals 0, this would give me x is equal to the square root of y squared, which again is going to be absolute value of y. And we know that looks like absolute value of y. There's your y-axis. Here's your x-axis. It's on its side. It looks like this. They're similar, but this is going to be in the z equals 0 plane. Z equals 0 plane is in the xy plane, and it's going to run along the x. So it's going to come out here like this, come in here and look like this. So you got up and down. Hard to see. This is up and down, and then it's side to side. Now, hang with me. My art will be perfect in a second. All right. So the next one, I'm going to make x equals 0 plane. But then that would be 0 is equal to the square root of y squared plus z squared. When you take two numbers, square them, add them together and take the square root of it and get 0, the only way you can do that is at one point, 0, 0, 0. So that gave me a dot in the YZ plane. But then I'm going to come over here and make x equal to 1. Something nice here. That would be 1 is equal to the square root of x squared plus y squared. This you could square both sides. You get 1 is equal to y squared plus z squared. What is this an equation of? You should recognize. And the zy plane, what is he? X squared plus y squared equals r squared. What is this equation of? Circle, right? Radius, in this case, 1, 1, 1, 1, 1 down here. And so you connect your dots. It's a circle. So over here at x equals 1, you're going to get a circle. And you get this cone coming out from the origin and getting bigger and bigger and bigger. But this is a cone. Does that make sense? Again, very visual on this stuff, but this is what you need to see. Now, yeah, okay, great. If you recognize the equation here, that this was supposed to be a cone, but it's not front and back. It's not one of these cones because I went ahead and took the square root of it. It's just one side of the cones. Does that make sense? A great question for a test and stuff. And notice how I picked out what my pictures are by using what we call level curves, by looking at x equals 0, y equals 0. Pick one of the numbers and get your 2D shapes and draw your 2D shapes on the 3D graph, and then connect the pictures, and that's what gives you that visual perspective. Does that help? Okay, keep going. I did promise some questions about WebWorks 7 because I heard at least from one of you guys that WebWorks 7 was giving you guys some fits. So they had particular problems on WebWorks 7 and they wanted me to, quote, take a look at it. I said, sure, I'll be happy to take a look at it with you guys. So let me pull this thing over here just a little bit. Okay. And get myself set up. All right, here we go. We blow this up. It says this. Give a vector parametric equation for the line through the point 3, -4 that is perpendicular to the line 5 plus t, 5 minus 4t. And I think it was the perpendiculars and the parallels that were messing most folks up. No problem there. All right, so let's see. First thing, get a visual for this thing here. So what do we got? Now, first off, you should recognize I got a vector. It is 5 plus t and 5 minus 4t. And it's a two-dimensional vector. Oh, that's even better. Back to my happy world. And in terms of my vector, the first component is x component, second component is the y component, 2D. Okay? So if I want to draw this guy out, and this is two-dimensional now, I can. X, y. And all you got to do to figure out a particular point is figure out your t, and this will be x, this will be y, and this will be what we plot. So you can graph this stuff. First off, I'm going to start with t equals 0. So if you get my initial point here, well, 5 minus 0 is 5, and 4 times 0 is 0, excuse me, and 5 minus 0 is 5. So I'm going through the point 5, 5. So that's up here at point 5, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm up here at this point. Now, let's make t equal 1. And let's see what the next point. And you know this is linear, so I'm looking for a line here. So t equals 1. I get 5 plus 1, which is 6. And I get 4 times 1, which is 4. 5 minus 4 is 1. And I get a new point, 6, 1. So here is 6. Here's 1 right here. And all I need is 2 points to make a line because they said it was a line. So connect my dots here. This is my line. Okay. Now, we want to give a parametric equation going through the point 3, -4, right? 1, 2, 3, 1, 2, 3, -4. We want to go through this point right here. This is my point, 3, -4, and I want to be what? Perpendicular. Perpendicular means I'm going to come in here and hit this guy at a 90-degree angle. I want the equation of this guy. Okay. But how do I get perpendicular? Well, you got lines. Can you not tell me now that you graphed this guy out what the slope of the line is? Slope, remember the old symbol, m? Rise over run, right? I'm going through this point and this point. So I had to drop down to here. So that's drop 1, 2, 3, 4. So that would be down 4 over 1. Down 4 over 1 to get to my next point. Yeah, I can also do the math if you really, really wanted me to. The slope is changing y. So this point was the 0.55. This point here was the 0.6, was it 1? Change in y. So that's 5 minus 1. 5 minus 1 over change in x. 5 minus 6. and you'll notice you'll end up getting a -4 slope on this guy. You can go old school on this thing. Does that make sense? Well, why do I care? Now that I know that my slope is -4, or better yet, -4/1, what would the perpendicular slope be from high school math that you're supposed to memorize? Right. When you get perpendicular slopes, the negative reciprocal, flip the fraction, change the sign, negative reciprocal. So that would be 1/4. Does that make sense? And if you want the equation of it, I mean, you kind of guide it here, but I'm going to show it to you. You can plot another point here. I want to go basically at this point, I want to go up 1 and then over 4, up 1 over 4 would put me at, let's see here, up 1 would be at -3 over 4 is 1, 2, 3, 4. It's going to be something like over here. Okay, it's hard to see on this thing here, but up 1 would make it over 4, and this would be comma 6 comma -3. It looks like, if you want to do it that way. And then, okay, it's supposed to be on the line there. Sorry about that. And you're supposed to actually, you can figure out the slope, but you got the slope on this guy. Okay, so what do we really want? We want the parametric form. Parametric form, x equals x naught plus at, comma, y equals y naught plus bt. Okay. Now this is your slope thing here. So if you look at it in the right way, this is that change in y over the change in x, right? And we got a point because we were supposed to go, might as well use the point they gave me. There's the point 3, -4. X naught is 3. Y naught is -4. All I need to do is know what my A and B are going to be. So here's the deal. It's rise over run x. This is the change in x. So that's going to be the 4. The B, so this is the B, the change in y is 1. That'll be plus 1t. So there it is right there. So the A is the change in x on your slope. B is going to be your change in y. When you plot your points out, you can go back and go through the old school there. But the last thing I want to do is give you the answer for this guy here. So I end up getting x to be equal to 3 plus 4t and y being equal to -4 plus t. But last thing, it's web work. You know, they're very particular about how they want you to write the answer. So they wanted you to write the answer in parametric vector form. Okay, and so, and the parametric vector form is basically the point as a vector, but typically we write it as a point, so you can use the round brackets, plus the direction, okay, vector times t. That is your form. Okay, and there's plus right there. Sorry about that. All right, so what was the point we were going through? You know, what was that point? It was 3, -4. It's this part right here. 3, -4. And then the components in terms of the t, the x component was 4, the y component was 1, and this is what you would type in on Weber. Did I lose you guys anywhere with this? Questions? It's 2 dimensions, so we're trying to get you guys to graph it. And again, where most people are messing this stuff up is they're looking too deep in formulas and they're not graphing this thing. Because once you see the pictures, hopefully more things will come back in your mind about how to graph this type of stuff. So question, yeah.
Can you explain the direction, like the vector direction?
Vector direction.
Or the second part of your answer that you got?
What the 4-1 thing here? Okay. All right. Well, first off, this is a slope, but tell you what, let's do this. All right. I plotted the point because I got that slope, rise over run, right? And I got a point over here, which was 3, -4. Now we're going through this point 4, -3, because that was given to us. And because of the slope being perpendicular, I found the slope of this line. So this is my perpendicular slope, 1/4. So I went from this point, I rise over run, and I end up getting the point, what was it? 6, -3, right? Make sure I do the math. Oh, I think it's supposed to be a 7. Hold on a second. Let's count it again. My slope was 1/4, so I had to rise 1, run 4. 1, 2, 3, 4. Yeah, it's supposed to be a rich 7. That's my fault there because I was trying to. So it's 7, -3. That's your 4. Okay, I never actually used this point, but it's 7, -3. How do you find a vector? Got 2 points. How do you find a vector? N minus beginning. All right, Merry Christmas. You want your vector? You got it. N minus beginning on the axis. 7 -3. N minus beginning, comma, N minus beginning. -3 minus -4. N minus beginning, right? That's what you get. 4, a minus 4 is +4, -3 + 4 is 1. There it is, happens to be the same number. So you could do 2 points on it. I did the rise over runs. The change in Y ends up becoming the B part, the change in X becomes A part. It's part of this. Okay. Sure. All right, try this one. All right, let me blow it up and guys sit back because I literally just cut, copy, pasted right off the web work these questions. So I took my little screen capture thing here. Here it is. Consider the line. This is number 13, by the way. This is the one WebWork gave me. Consider the line L of t equals 5t minus 2, comma 6 minus 2t. When and then you're supposed to tell me the x-axis is at the point what? The x-axis as intersects, L intersects. The x-axis at the point what when t equals what? The y-axis at what point when t equals what? And the parabola at what 2 points and what are the 2 times it intersects? All right, this is all about intersection. I actually put one of these kind of homework problems. It was only the linear stuff on your test review. So here we go. Well, how am I going to end up doing this? Well, first off, part number 1 right here, we want to talk about where the x axis, okay, is going through what point? Okay. Well, how do you cross the x-axis? You cross the x-axis would be at a point x comma 0. You pretty much make y equals 0, right? This is called an x-intercept. X crosses the x-axis, x-intercept, x comma y equals 0. So when we know we got this linear equation, L of t equals 5 minus 2 comma 6 minus 5 minus 2t comma 6 minus 2t there. But I know for the x-intercept, the y coordinate has to be what? 0. So this is your x component, y component. So take the y component, which is the 6 minus 2t, and set him equal to 0, and you can figure out the time it hits. Question. Oh, 5t minus 2. Oh, sorry about that. That'll make a difference on the next problem. Okay, 5t minus 2. Okay. But does that make sense? I'm looking for it's going to cross the x-intercept, x-axis, cross the x-axis, which means y equals 0. So I take the y component of my vector, which is in terms of time, and I can solve for the time. Solving for the time, I don't think I need to do the math here. Add 2t and divide by 2. What do I get? T equals 3. So at the point, and t equals, t is going to be equal to 3. That's where you hit. And so what would the point be? Where are you going to cross it at? Well, I know if you're crossing the x-axis, y equals 0. How do I figure out the x-coordinate? Now here comes the x-coordinate is 5t minus 2. So that would be 5. We know the time now, 3 minus 2. 15 minus 2 is 13. X is 13. So that would be at the point 13 comma 0. Does that make sense? All right. So this would be the point 13 comma 0. It occurred at t equals 3. Now you want to cross the y-axis, intersect the y-axis. So to intersect the y-axis at the particular point, we want to know what the point is and what time you actually hit it on. So again, here's my L of t equation, which was, get it right this time, 5t minus 2 comma 6 minus 2t. But to cross the y-axis, this is called the y-intercept. You're going to go through the point x equals 0 comma y. That's what the y-intercept is. You said x equals 0. So here we go. So I'm going to take the x, which is the 5t minus 2, set it equal to 0, and that gives me t is equal to 2/5 or 0.4 for you decimal plans. So you guys above decimals, the answer is 0.4, or you can also write 2/5 in there. What would the point be? Well, once again, your point is going to be, well, x is equal to 5t minus 2, and you plug in your time, but you know the x-intercept is going to be 0, but the y is equal to, what was it, 6 minus 2t. So that would be 6 minus 2 times 0.4. And again, let's stick it on the calculator here. 6 minus 2 times 0.4. And I get what, 5.2? That's right, it's decimals now. So you get the point 0, 5.2. I lose you guys anywhere there. Then take a look at part 3. The parabola y equals x squared is going to intersect at 2 points and at 2 different times. Well, how in the world am I going to do that? Well, y equals x squared. Remember my linear equation, which is, what was it? 5t minus 2, comma, 6 minus 2t. This is your x, this is your y. You know what I'm going to do here. I got to, everything based upon these lines is based upon time. I got to figure out the time. So I'm going to plug this stuff over here. So this would be 6 minus 2t is equal to parentheses 5t minus 2 quantity squared. So I'm going to clean this up. This is 6 minus 2t is equal to, and I'm going to FOIL this out. That would be 25t squared minus 20t plus 4. And now it's being a quadratic. I'm going to set it equal to 0. So I'm going to subtract 6 from both sides. I'm going to add 2t to both sides. This gives me 0 is equal to 25t squared minus 18t minus 2. You will notice this thing is crappy because it doesn't factor. But luckily, we all passed high school and we have the quadratic formula. So t would be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So t would be equal to negative 18, b is negative 18, plus or minus the square root of negative 18 squared minus 4 times a, which is 25, times c, which is negative 2, all over 2 times a, which is 25. And it gives me 2 crappy decimals, right? And the 2 crappy decimals, just to let you know, I did go ahead and do this on the calculator, is 0.8178209257. And the other t is equal to a negative 0.09782857. Okay, so I ran out of room there. All right, but that gives me 2 times. Remember, this is web work, no rounding. I've already had students come by my office tell me web work's broken. Nope, 3 decimal places, you're broken. I want 9, all decimal places. Web work is the deal. All right, so, and now that I got these 2 times, how do I get the points? What am I going to do? I'll let you finish this one up. How do I get the points? You plug it back into the L of t, that'll give you the x, that'll give you the y, so you can go and answer the question. You'll get 2 points. It'll be an ordered pair, and you put your 2 times respectively in there. Does that make sense? And the last one, number 13, was about parallel and perpendicular. And the big deal about this one is draw it out. Then look at the slopes, just like we did with the other ones. Draw this thing out. T equals 0, t equals 1, make a line. Draw this out. T equals 0, t equals 1. Perpendicular and parallel, and you'll see it, or it'll be neither, stuff like that. Study hard on this stuff. Don't forget, you got your test review due on Monday at the beginning of class. See you guys then.